It'll be there eventually. So what we'll talk about just a brief introduction of who I am, talk about 8K cameras and codecs, and then getting into like the actual workstation hardware, workflow kind of things you want to consider or keep in mind if you're going to be getting like new systems in the next couple of years. So very, very, very brief. I don't want this to be a marketing spiel. So what we do is we do high performance workstations for video editing, engineering, all that kind of stuff. We focus a lot more on the relationship between our customers and ourselves, because in the end, a computer is a box of parts and anyone can build a box of parts. We do a lot of our solutions are by software package rather than like obscure model numbers that no one understands. So like if you're using Premiere Pro, we got systems for that, or DaVinci Resolve, and those kind of things. We also do a whole bunch of publications and testing. That's one of the things that sets us a little bit apart is we don't just throw stuff into a box and hope it works. We actually test inside of Premiere Pro or DaVinci Resolve when Intel launches new CPUs or AMD or new video cards and all that kind of stuff. So we put in all of the testing to figure out exactly how much faster they are, what things do you need for something like 8K, or if you're doing 4K or whatever. And it turns into a whole bunch of charts and numbers and way too much stuff that then no one actually ever reads because it's way too many numbers. Okay, so that's my very quick spiel about who I am and where I come from. So starting off, I think 8K cameras and codecs is the place to start, because this is really where your choice of what hardware or what kind of workflow you need to do is going to begin. And it really comes down to two kind of groups of cameras. I don't really want to talk about the pros and cons for one kind of camera over another. Honestly, that's not my specialty. I couldn't help you with that anyway. But it really comes down to you have kind of two groups. The first is the red cameras. They've been around for quite a while, able to do 8K. The main thing with those when it comes to like workflow is that they record using red RAW. And so that's RAW. You have extra steps of debayering, turning the raw sensor data into usable images, and they're quite high bit rate. So at the highest end, you're going to be somewhere around 2,000 megabit. So compare that to something like H.264, that's a huge amount. So things like storage speed is going to come into play, or if you're working over the network speed. And then the other kind of group is kind of almost everything else. So Sharp and Sony and Panasonic now all have 8K cameras. The thing that kind of lumps those all together is the fact that they record using H.265 or HEVC. Most of those cameras will record at up to 200 megabit. Some of them I think might go up to 250. I think most people are actually going to be recording in like the 100 to 150 range, but it's always good to think about like the maximum when you are going to be looking at, again, storage speed is the main thing that's going to come into play. So the codecs, a little bit deeper into them, Red Raw is really interesting just in general because it uses the GPU. I don't think there's any other raw codec that uses the GPU for debayering. And so that just makes it the GPU is incredibly important. That's especially a good thing to bring up here at PNY's booth, because obviously that's going to be a place where video card is really, really, really important. And then H.265 is, first of all, it's terrible to work with. If any of you guys have worked with H.264, I'm sure you have. It's awful to work with. There is some hardware accelerated decoding that can be done. Premiere and After Effects both use Intel QuickSync. The problem is that that's only available on their like consumer line of CPUs, and those typically don't have enough processing power to handle 8K. So unfortunately, that's not super useful. And then you have Resolve, where it's using NVIDIA-based processing for H.265. So the GPU can help, even if you're doing H.265, but it's mostly going to be in DaVinci Resolve. If you're using Avid, Premiere, or pretty much any of the other ones, right now it doesn't support native GPU acceleration, which is unfortunate. So what can you do today? We have a system demoing back there, kind of the best you can do for 8K, or that one's also doing 6K. So right now, if you're looking to edit in 8K, what can you actually reasonably expect? I always put way too many numbers. It's basically for 8K red, you can get about half res, as long as you're okay with half res at 24 FPS, you can process that real time, you're good. If you bump up to 30 FPS, then you kind of have to go down to quarter res in Premiere. It's still half decode quality, but it's just the good in like Resolve. And that's kind of the limit. Like if you're for whatever reason doing 60 FPS, yeah, you're going to have a tough time. I don't care what your budget is. You could have 100 grand to throw at it. You're not going to be able to be processing that in real time at anything really reasonable. H265 is actually surprisingly very similar. I did just pull 100 megabit here. So if you are going to the upper end of the bit rate, 200 megabit, you're probably just not going to. Like that's just kind of how it is today. So the short of it is, as long as you're working at 30 FPS, you should be able to get away with working natively without proxies, as long as you're okay with not having full res. Which honestly, I don't think anyone is using an 8K monitor while they're editing. So having it at half res, you're still at equivalent of 4K. So you're going to be probably okay. So that's kind of what you can do today. There are some things coming that are really, really interesting that is going to change some of this. The biggest thing is that Red and NVIDIA are working together on an update to Red's SDK. So how you actually process Red footage in Premiere or Resolve, they're working on an update right now. And then when it comes to hardware, so a lot of the people we work with don't care about hardware. That's kind of what we do, and our customers are editors. Like, they just want it to work, they just wanted to get it done. But I do want to bring up some just little bits of specifics, just so that when you go into getting a system that needs to be able to do what you're doing with 8K, that you at least know that you're on the right track. I will also mention here that, especially since we're talking so much about like video cards and NVIDIA, that I'm mostly focusing on the PC side. If you have questions on the Mac side, I'm happy to answer any questions afterwards, but since we've only got 20 minutes, I'm gonna focus more on the PC. But a lot of this stuff does apply to Mac, so you just it might not just be perfect. So what kind of influences the entire experience of going in and editing, whether it's 8K or 4K or even HD? Excuse my terrible, I'm not a graphic design artist, but this is as good as I can do. So it's kind of this kind of building kind of model. You have at the very bottom, you have a foundation. These are things that you absolutely have to have before you can really consider doing any sort of editing. So you have RAM, the system memory, so it's like temporary storage, and then you have your long-term storage, whether it's internal or external, if you're working over Thunderbolt or a NAS. This is all the stuff you have to have in place and have enough of it and fast enough of it, or else the entire experience is just gonna be terrible. And then you have like these pillars that are more like performance. So these are the things that actually influence like what resolution you can edit at and how fast you can do it, what frame rate. And you have the CPU, processor is a big one. Then you've got the GPU. And then you have I just kind of lumped it into other and everything else, which I'm not really gonna cover, but this would be things like your sound system does influence how you edit. Your displays, whether it's 10-bit or 8-bit, how much copy you have available, that falls kind of under other. And that all contributes towards the experience of how fast and how efficiently you can edit. So I'm just going to kind of break these down and just go through them one by one pretty quick. So storage is a big foundation. And this is usually one that people have the least problem with, because I mean, first of all, you just have to have enough. Like, yeah, if you're shooting Red and it's 2000 megabit, you need to have enough to be able to handle all of the files that you're going to be working with. You have speed. This is a little bit more complicated. The way I usually try to think of it is take your bit rate of what you're recording, add 50%, and that's how fast the drive has to be per user. So if you're going over a NAS, you have to multiply this by 2 or 3, or however many people might be simultaneously using it. So it works out if you're going to be using one of those like Sharp or other cameras that do H265, you need a drive or storage that can do 300 megabit per second, which translates to 40 megabytes per second. And that's one thing that a lot of people kind of miss, is that footage and like networking is usually in megabit per second. A lot of storage speed stuff is in megabytes per second. And there's 8 bytes in a bit, which makes it very fun to do conversions. But so you kind of have to make sure that you're not needing, you don't need a drive that's 300 megabytes per second speed, you need a drive that's 40 for H265, sorry. And then Red is pretty much just times 10. So you need a drive that can supply about 400 megabytes per second in terms of speed. Now this is again on kind of the upper end. So if you are not actually recording red at 2000 megabit, you're actually only doing it at 1000. It's actually half of that, but it's kind of nice just to think. It's kind of nice just to think in terms of the maximum you'll need. And then the last is always connectivity. Internal is always going to be best, but that's not always practical. You have multiple people working on a project, you can't have internal storage, at least not practically. So you have a couple of different routes. You can go with a NAS or SAN solution, so that's network-based. The big thing to keep in mind there is that gigabit networking, which most things these days have. Laptops will have gigabit. Any desktop you buy that's at all decent should have gigabit. But if you're going to be working with Red, that's where you'll need to jump up to 10G, and that is not standard on a lot of systems. So you might either have to have an add-on card or something like that to get 10G. And then always remember that connectivity is only one part of it, and same with the drive speed itself. If you have a super duper fast drive, but it's connected via USB 2, it's going to be terrible. If you have 10G networking or Thunderbolt, but then you're going to a slow ladder drive, it's going to be terrible. So I usually try to not even worry about like the official specs that anyone produces. I mean, there's a lot of great like NAS solutions out here, but honestly, I just run a system or a benchmark, just a hard drive benchmark. AJA System Test is a good one. Crystal Disk Mark is one we use internally just because it's so easy to use. If you do run them, you basically just get a page like this. You just have to look at the read performance, at least for like editing. So that's just kind of so in this case, this drive is about 700 something megabytes per second, which means it should be able to do at minimum one person working with red footage off of that drive. Probably practically you can get away with 2 or 3. It just depends again on the bit rate and how much people are actually working together at the same time. So that's kind of storage. RAM and system memory is way easier. You just get enough. Don't worry about speed. Don't worry about anything else, really. It's just get enough. And if you're talking about doing 8K, just get 128 gigs. That's what you need. You might be able to get away with 64 gigs in some cases, but honestly, RAM is getting so cheap these days. It's not that much more expensive. Just get 128 gigs and just be happy. And then when you get to actual things that impact performance, because again, storage and RAM, you need to have enough and it needs to be fast enough, or else nothing else you do is going to be good. But like things like CPU and GPU, you can get away with different levels of performance depending on the bit rate that you're working with, the type of footage you're working, red or H265, and like what preview quality you're willing to work with. And GPU acceleration is the big thing. I mean, obviously in White's booth, we're going to talk about GPU acceleration a lot, but CPU is still foundation. A lot of things are still just completely based on the CPU, so you really need a good processor to do this. A couple questions we always get: AMD or Intel? Right now, it's Intel. If you're talking about 8K, you should go with Intel. AMD is doing some really, really nice stuff right now, but that's more mid-range. That's more if you're talking about like doing 4K, then AMD can be an attractive option. But 8K, it's just Intel right now. There's the Core versus Xeon line. So this is like their mainstream stuff versus their workstation class stuff, the Xeon. A lot of it oftentimes comes down to people's budget, because the Core line is higher performance, both per dollar and total, just barely. Xeon does allow the use for what's called error correcting memory, and that is to correct really random issues. So like a solar flare happens and it flips a bit, it can correct that kind of stuff on the fly. It's really only for like mission critical workstations is kind of how we tend to classify it, where you would need Xeon. Oftentimes for us, that translates to people that are like freelancers or small studios go the Core line just because you can get a whole lot more performance for your dollar. And then like the larger studios, people like HBO, ABC, not even that big, but like the slightly larger, they go Xeon simply because that slight bit of extra reliability with ECC RAM is worth like almost any money to them, because any downtime to them is money lost. So like, yeah, we'll spend an extra $500, like who cares? And then there's always this whole thing about more cores is more better. Intel and AMD are going on a big kick of just adding more cores, and that's one of the biggest things you'll see in terms of like marketing. The problem is that it's not really always better, especially if you take it to the extremes. You can still find like big dual Xeon workstations that have 2 actual physical CPUs in them. they have a lot of overhead, and if the software is not really, really, really good at using all those cores, there's a lot of actual performance drop. So it ends up being slower than a single CPU system. So in general, no, it's not always more cores is better. It comes down to the actual real world performance of those CPUs, which kind of comes back to where I started about how we do all of this extra testing to find out exactly what CPUs those are. And it translates into, well, what do we recommend? If you're doing 8K, this is kind of our recommendation. If you're on the core line, so you can't quite get up to the Xeon stuff, it's the X series from Intel. The two highest end models are right there. Very small performance difference between those two. It's a handful of percent. So then it comes down to, well, can you afford that extra $300 or $400 or not? On the Xeon line side, you really just need to go up to the highest end Xeon W. That's their workstation class Xeons. So the 18 core there. And that's really any of our customers that are doing 8K editing, that's pretty much the only CPUs we use. Anything below that, you start to have performance issues. And then you have the GPU. And so this is kind of where everything is kind of taking a quick exit right now, because CPU processing for the longest time, like 20 years, has been how everything was done. And now GPU acceleration is becoming more and more important. We talked about earlier with Red, how the debayering is done on the GPU. They're going to be adding decoding to being done on the GPU. It's also now like a lot of effects. So if you guys are in Premiere, things like Lumetri color, that kind of stuff is all GPU accelerated. DaVinci Resolve does this even more. So any like open effects you're doing, any noise reduction in Resolve uses the GPU extremely heavily. So it's becoming more and more and more a part of the performance equation is the GPU. And it's in very different stages in different NLEs. Resolve uses the GPU extremely well. Like you can put 4 GPUs and it'll use all of them. Premiere Pro, not so much. Like single GPU, you'll be good. It's more about having enough of a GPU than a particularly super crazy, crazy GPU in most cases. And then things like Avid or Vegas, if you guys are using that, it's pretty similar to Premiere. Avid tends to lag a little bit behind a little bit. They're a lot more about stability than having the newest and latest and greatest kind of support. So questions we always get, just like the CPU, in this case it's AMD or NVIDIA. The fact is NVIDIA has better top-end performance. Kind of like the CPU, AMD is really great in the mid-range, but they don't have any product offering that goes like to the really high part of the stack. So in that case, it's pretty much NVIDIA is your only option if you're looking to get the highest performance, especially for something like 8K. GeForce or Quadro is one we get all the time. Just like the Core and Xeon on CPUs, it's kind of the mainstream stuff that was traditionally made for gaming, and then Quadro is the professional, the stuff you should be using if you are doing anything like video editing. It comes down to GeForce is a lot cheaper, but it has less VRAM, so that's memory built into the video card, and that's very important for 8K because you need a lot. Like you're processing huge amounts of data, you need a lot of VRAM. So there's really only like one and kind of a second model of the GeForce side that is even practical to use for 8K editing at all. And then the Quadro side is kind of the inverse. It has more VRAM, so it's a lot easier to do 8K editing with. It is more reliable. Our failure stats puts it at about 15% more reliable than GeForce, but that's after all of our product qualification where we throw out all the bad models and after our initial testing and burn-in and everything. So that's kind of a best case scenario, honestly, for GeForce is that 15% less reliability. So in practical times, if you're either building your own system or buying from a different company, it'd probably be a little bit more than that. They do also tend to have less driver issues. Simply because they don't do a whole bunch of driver updates when like a new video game comes out, and they don't put in all these like updates for that kind of stuff, which oftentimes breaks other things. That's also very interesting though right now because NVIDIA is doing what they're called studio drivers for GeForce, where they are doing some of that extra application qualification for GeForce cards. They are doing like less often updates so that they're more stable. They also even just announced yesterday, I'm pretty sure here, that they're enabling 10-bit display support on GeForce. That was historically reserved entirely for Quadro, and now they enable it on GeForce. So there is a little bit of an odd thing going on with NVIDIA right now where they seem to understand that a lot of, especially like freelancers and smaller studios are using GeForce simply because the amount of performance you can get for your dollar. So they're trying to provide some support for those people. But on the higher end, if you can afford it, Quadro is probably the better route to go if you are doing especially 8K because of how much video memory you need. So our recommendations, it gets a little more confusing rather than the CPU one, simply because it does depend on your application. But it's basically, if you're on the GeForce side, the 2080 Ti is a great one for Premiere. It doesn't have quite enough VRAM if you are using Resolve though. Resolve doing 8K, you need about 20 gigs of video memory. So for Resolve, for those kind of customers, we would typically jump up to what's called the Titan line, which is kind of an odd one. It kind of straddles in between GeForce and Quadro, and every model they release they go back and forth, whether it's more GeForce and gaming or whether it's more professional. Right now it's on the more professional side. So you can use up to 2 of those cards for DaVinci Resolve. And then for the Quadro line, they are more expensive, which is why I put in kind of a second one here, because if you're doing H265, Premiere Pro doesn't use the GPU to accelerate H265 stuff, so you can get away with a lower end card, something like an RTX 5000. But if you're doing Red, you really need as much processing power as you can get. So that's where like the RTX 6000 is. There is another higher end model called the RTX 8000. That is actually not any faster than the RTX 6000. It just has more memory. But memory is the kind of thing where as long as you have enough, you're good. So the RTX 6000 should have plenty for Premiere Pro. Then DaVinci Resolve, very similar to the GeForce stuff. The Quadro RTX 6000 is really what you should be using for that. It eats video memory like candy. And you can do anywhere from 2 to 4, and that depends on how much like open effects you use or noise reduction you're going to be doing. That's where you're going to see a benefit to having more than 2 video cards in DaVinci Resolve. And it's not always a huge benefit. Each card you add is something like 30% more performance. So do keep in mind that putting 2 cards in isn't twice as fast. 3 cards in isn't 3 times as fast. It is diminishing returns. And then again, there's all the other stuff. Display is always something you definitely need to be keeping in mind. If you are needing a reference monitor, you'd want to look into using something like a deck link so you can get a really good, clean video signal out to your reference monitor rather than going through the GPU. Audio is a big thing. Control panels, desks, chairs, coffee, Red Bull, all that kind of stuff, all really contributes. And I think that was actually it. I was trying to keep this one nice and short and to the point. If you are looking for more information, our systems are up there if you want to go straight to those. Our contact info, that's our SIGGRAPH page showing where we're at. And we have a booth kind of back towards just kind of the back corner. We're also here in the PNY booth. We're also in the Boris Effects booth somewhere. I think it's over there. So we've got systems all over the place. Any questions about any of this? AKA, yeah.
So I noticed when you were talking about CPUs, you said no AMD.
Yeah.
Do you suspect when they come out with their 16-core Ryzen and Threadripper later this year, that'll change, especially with PCI Express 4.0?
The question was about AMD's new stuff that they're releasing soon on the CPU side, because they just did a product launch now. They still have one more model to release, and then they're revamping their higher end, what they call Threadripper line sometime. I don't think they've officially said when. I don't think that one last Ryzen is going to make a huge difference, simply because you need more than I think just adding a few more cores will add. The Threadripper stuff very well might. I think it's completely too early to even guess, because their current Threadripper has a lot of issues, like scheduling issues, because of how they had to kind of fudge things in order to get crazy high core counts. I think that one we just have to wait and see. We just have no idea.